Every garden here uses the same 20 meters of fence, yet some hold much more ground than others. So which shape wins? It feels like the fence is what you pay for, so the same fence should buy the same ground. But it doesn't. Let's measure instead of guessing. The fence stays 20 meters around, so width plus height never changes, and the panel walks through every whole number rectangle for us. A pattern shows up right away. Whenever the two sides move closer together, the garden grows. The long, thin strip holds the least ground, and the square holds the most. Why should balance win? Here's a picture that answers it exactly. First, draw the balanced garden, the square whose side is the average of the two sides. Now take any lopsided rectangle and cut a strip off its long side, just enough to bring that side down to the average. Stand the strip upright on top of what is left. The two pieces fill the balanced square almost perfectly, but one corner stays empty. That hole is itself a square, and its side is exactly half the difference between the sides you started with. So every rectangle is the balanced square with a corner missing. Now look back at the score panel. The areas we lost were never random. Each one is a perfect square, and the more lopsided the garden, the bigger the hole. Now turn the picture into algebra. Our identity says the product of the two sides equals the average squared minus the whole squared. But the whole is a genuine square, so its area can never be negative. Take away something that can only shrink the total or leave it untouched, and the product always lands at or below the average squared. It reaches that ceiling in just one case, when the whole disappears, which is exactly when the two sides are equal. This inequality is worth knowing by name. The average of the two sides, a plus b over 2, is what we call their arithmetic mean. Now take the square root of both sides of what we proved. The product becomes the square root of a times b, and that is their geometric mean. So here's the whole thing in words. The arithmetic mean of two positive numbers is never smaller than their geometric mean. That is the AMGM inequality. You did not memorize it. You watched a corner prove it. And with more than two numbers, it still holds, though that proof needs more than one picture. When two quantities share a fixed sum, their product is biggest when they are equal, and the price of imbalance is the square of half the difference. If you have met completing the square, you have seen this missing corner. More problems like this on Mathalon.